Good. Well, good morning, everyone. Thanks very much for joining us for this session, where we're going to talk about closing some of the automation and DNS security gaps in today's environment. And for most of us, we know there are major challenges going on across the organization, across the world. Proliferation of devices, the amount of traffic going across, public cloud, private cloud, OpenStacks, multiple OpenStacks, really trying to make these things work in your environment. Whether you're on the enterprise side or on the SP side, that becomes a major challenge for a lot of different organizations. And most times we think of this in kind of three key areas. Availability. I need to make sure everything's up and running all the time. I can't have downtime, I can't have that risk, I can't have latency, and I have to merge these multiple hybrid environments as part of the process as well. Security is always a big overlay. This session, you might not be security focused, but there are some security angles you need to think about from a DNS perspective that can reduce some of the pain associated with some of the things you might see across your organization. And then efficiency. Sitting in the booth, talking to customers last day and a half, we hear this all the time. We have so many manual steps, manual processes, multiple silos, multiple stacks. How do I become more effective across this heterogeneous environment? At a high level for Infoblox, what we do, we'll get through some demos here coming in a second, but setting the stage. What we're known for is core network services, DNS, DHCP, IP address management, make sure you have that highly available core network. Securing DNS, giving you a lot more visibility, a lot more security on top of DNS, and then cloud network automation. Having the visibility, having the automation capabilities to help manage it, have some of the efficiencies going forward, all on a centralized management platform. Infoblox has been around about 15 years. We have over 220 SP customers. We have about 50% market share on the enterprise-grade DDI space. So again, we know this space, we live and breathe this, and this is kind of our key focus areas and what we're delivering to our customers today as well as going forward. Again, that was kind of a high-level walkthrough of who we are, what we do. I really want to spend more time on the availability and efficiency and the security with some demos coming up. Again, at a high level with Infoblox, DNS, DHCP, IP address management, scalable platform, distributed platform, again, across your multiple environments. Even though we're at OpenStack, most of us have a plethora of different environments. On-prem, private cloud, public cloud, bringing them all together. We have that capability to help you make it very simple for control as well as visibility. We're going to have a couple of demos coming up here in a second. The first one's going to walk through the scalability piece. When I talk about availability being so critical for an organization, DNS, kind of plumbing, not the sexiest thing in the world, but if it doesn't work or you don't have enough, it's a problem. So I need to have that elastic scalability. So whether I'm getting good usage coming through or I want to scale based on the customer's needs, or I got some bad actors causing problems trying to flood the network and take you down, you need to scale to handle those requirements, and we can help with that. In addition, some of the challenges in automation, when we walk through the demo with Phil coming up here in a second, a lot of us are trying to get to that fully orchestrated piece. From a networking perspective, we're not quite there yet. You think about what do you need? I need an IP address, I need a DNS record to make things work. How do you do that today? Do you own it all? Do you make sure you get it from the right IP address space you want it from? Does your DNS naming make sense? Can it go from DevOps to public to private cloud along the way? How do I handle some of those key capabilities is a challenge. So anytime you have a multiple handoff, a multiple step going to a different team, that's going to slow your process when we think about dealing with the automation, dealing with the dynamic nature you want to have across your deployments. So again, at a high level, I want to kind of set the stage for you. I have Phil Miller coming up, who's a solution architect for us. He's going to walk through a couple demos showing you some of these key capabilities, both for availability and automation.
Thank you, Matt. Yeah, so to start with the elastic scaling functionality, like all good software companies, Infoblox is eating our own dog food here. We're scaling new Infoblox DNS servers here, leveraging heat. So there's a hot template that's been deployed here. It's running our control plane we call the grid master. And the next step that we'll do here is show you that stack. So all of the details, there's a Nova server, there's a number of subnets, interfaces, fixed ports, and what have you. Each of these individual objects within heat have simply been scaled, right? So now we need more DNS servers. Our DNS server is either coming under attack or is just growing due to standardized load. So what we do is scale up based on policy. So the policy will state something like, at 15,000 queries per second, I need a new DNS server. At 10,000 queries per second, I can go ahead and retire one. So there's a scale up and a scale down policy that's associated with each of these. Those are standard heat objects. There's a list of Infoblox heat objects that you can pull in from our plugin on GitHub as well. Please do visit Infoblox Open on GitHub for those. And we've got example code for everything there. So I'm the first person to raise my hand and tell you I don't write a lick of Python code, but I can copy and paste like the Dickens, right? So all of those examples are there for you. It's really easy to deploy. The YAML is already written. And you just modify the little bits and pieces you need to make it work in your environment. Right, so here we're just highlighting the example of the scale down policy, the scale up policy, as it were, and how many new servers at a time. In some cases you want 10, in some cases you want 100. It completely depends on your project, your tenant space, and your customers' needs. So in the next example, we're going to do a bit more orchestration around the actual data sets. So in the first one, we were scaling up and scaling down DNS servers themselves. In this case, we'll be scaling and adding and removing data. So you can see in this use case, we're running Docker instead of a KVM workload or something like that. And what we're doing is adding a tagged network. So all objects in the Infoblox database can be tagged with metadata. And that can help you segregate data from customer A, customer B, customer C, project A, project B, project C. And so what we're doing here is building, Docker's running its magic here. This code never existed, so it just goes out to the hub, pulls it down, launches itself, and lo and behold, now we have a cloud from what we call the cloud adapter, the Infoblox network cloud adapter. And that's stored in our database as well. So you can see where you can overlay OpenStack data, Docker data, VMware data, your own metadata, and we can also crawl and probe the traditional network through VLAN discovery, end host, bridge, ARP tables, all that good stuff. So at the end of the day, you've gotten an entire stack of data, if you will, that shows you everything from the workload all the way to the top. So here we've created these two networks, both using the cloud adapter. There was zero human interaction here that generated these two networks. It's the cloud adapter that's running as part of the CNI connection. And spitting up something like a BusyBox generates an IP address and that MAC address. And again, stored in the Infoblox database. So this, what that means is you get instant replication of this data across your entire distributed architecture from a DDI perspective, and centralized visibility of the entire solution. So it's really nice and all that you can plug in lots and lots and lots of data into the solution, but there's the dirty little secret that nobody likes to talk about called network cleanup, right? So it's really important that when workloads are retired, especially in the case of something like a containerized workload, these are traditionally very ephemeral, you need to clean up after that. So the IP address is retired, the MAC address is retired, and the DNS name goes out with it as well. So this way you're never left with stale, dangling DNS records and data that could potentially get you in trouble. So we'll do the same thing, connecting and disconnecting Docker networks from an existing workload here. Again, publishing and cleaning up after the data set has come and gone. Pop to the next one. And so in this case, we'll be speaking the API suite for Nova and Neutron. We authenticate via Keystone, and we collect our data from there. So same story, different methodology. In this case, what we're doing with nothing more than a username and a password, we're able to log into the entire project list, collect all of the running virtual machines, and learn from Neutron all of the port details, the subnet details, so on and so forth. And we can also automate, again, the addition of a DNS record here. So based on a few variables, you can very quickly and very easily collect an entire cloud's worth of data and metadata and have it stored within Infoblox, not only for visibility, but also for services purposes. Again, the ability to just read a bunch of IP addresses and turn them into DNS names based on your requirements and your policy. So that Cloud V discovery functionality speaks a number of APIs, again, including the entire OpenStack suite, VMware, and some public cloud as well. So we can log into solutions like Azure and AWS and collect the same amount of details. So a single pane of glass for all of your virtual workloads.
Cool.
Cheers.
Yeah, thanks, Phil. So again, that was kind of covering some of the automation capabilities and the scalability piece to it. The one last thing we want to talk about is a little bit security and the end user from a DNS perspective. Again, depending on your responsibility, security might not be your primary focus, but from an organizational point of view, it should be something we consider. And DNS is the #1 fastest threat vector when it comes to security. A lot of people don't think about that, but why? Well, you think about where is DNS? DNS is everywhere it's critical, so it's a high-profile attack vector. Typically, DNS was designed to be what? Open and allow everything. So if you have a security background, does open and allow everything make you feel comfortable? Typically not. And that's a danger area we see with it. So one of the challenges, the bad guys are using DNS as a way to come in, and you can reduce some of that risk by leveraging a DNS-based tool because you can make a point of control to reduce some of the risk. You need visibility into what's going on. Try to find some of those trends before they become major problems across an organization, and try to bridge that gap between the silos. You know, the silos are always a challenge between SecOps and NetOps, but we want to try to bridge that gap. Now, everybody in this room probably already spends a boatload when it comes to security tools, so don't they catch this? Typically, no. The reason why is the fastest growing threat vector? Because it works. If it didn't work, if your next-gen firewall, your proxies caught this, it would solve these problems. So again, we invest in things like web proxies and email proxies for specific problems, but we leave DNS kind of open and allow everything. And there's three key areas where it can impact: malware propagation, lack of visibility of what's going on, and data exfiltration. Data exfiltration is a very scary thing to think about. If somebody gets in your network, they want to get stuff back out. A lot of times they'll use DNS tunneling as a way to do that. They'll send it out across the network, your firewalls, everything else says, hey, it looks like DNS, allow it to go through. And that's a major, major danger area. And that's where our next demo is going to focus on, just kind of showing you how data exfiltration can cause problems, how information can get across the network, and more importantly, how to stop it.
Thanks again, Matt. So the story here is Infoblox has already launched our VNF. That is, we are a DNS server running in this particular OpenStack project. And that virtual ADP that you see there stands for Virtual Advanced DNS Protection. So the Advanced DNS Protection Suite will be processing every single DNS packet that goes through that super highway known as port 53. As Matt said earlier, every single firewall basically on planet Earth is permitting port 53. It's a necessary service in order to make connections work. So this particular tool suite that we're running here takes data exfiltration and shows you intellectual property as being pilfered by a bad actor. Right? So what we do is we select the file here, and then we go ahead and bit chunk it into a series of queries. And what will happen is when we click on transfer the file, all of those bits and bytes you see zipping by on the bottom of that screen, that's the actual file. It's been turned into DNS queries. And then on the far end there, the received chunks bit that you're seeing means the bad actor on the other end is receiving those queries, putting that log back together again, and now has your list of credit cards, your customers' private sensitive information, all of the stuff that you're trying to protect, right? And so at the end of the day, what winds up happening is you get all the way through, and with the help of one of my favorite supervillains here, we can see that a really bad thing has happened on the network, right? The Joker did what he was there to do. He stole data, and that whole image made its way all the way through. So if we go ahead and run this same example through again, leveraging Infoblox's secure DNS topology, what we'll see is even though a little bit of the data gets through, the vast bulk majority of it does not, and that's a zero-day protection. Right? This is not something like an antivirus solution where we know what the bad actor is, or we can just pattern match against something. What we need to do is some deep data analysis and determine whether or not, based on analytics, on the fly, this is a good or a bad DNS query. And so what we're doing here is just starting up that service. It takes just a moment for it to start up and apply itself to the DNS solution. And then the grid is now running threat analytics. So now, as we run through the same tool suite again, we'll see that our logging system and our interactive threat protection system will go ahead and block that solution quite automatically. So we're just going to look for some CEF in here. So as Infoblox protects you, we also try and speak as many open protocols as possible. We do north and southbound RESTful API, and of course our logging in CEF format. That makes for very easy ingestion into the rest of your ecosystem, various CM tools, and of course any other homegrown tools you may have. So here we go, we're going to select that file. We're going to plug it in and start turning him into DNS queries. And we'll notice, if we follow along there on that received chunks line, things look a little bit different this time around. So we've sent 17, 18, 20, 30, 50. These chunks are going through, and as far as this bad actor, as far as this piece of malware is concerned, it's very happily sending the data, right? It's doing its job. It snuck its way into your network, and it's sending data out, except for received chunks quit climbing. So what has happened there is the Infoblox solution has determined that this is a bad DNS set of queries, and it's gone ahead and blocked it. So the client is still sending. It's a UDP, it's a stateless pile of traffic, so this client has no way of telling that command and control is not receiving this data, although all the while Infoblox is protecting this particular piece of data. It's not allowing it to exfiltrate over that port 53, and it's alerting the entire SOC that this is going on, right? So if you happen to be a human instead of a CM system and you're not ingesting syslog for a living, there's also a number of very good graphical dashboards that are built in for real-time analysis of these anomalies on the network as well. So you can see, the standard red light, green light, 1, 2, 3 kind of a thing. It shows you very big important things in bright red. It makes it quite obvious where the indicators of compromise are and provides all of the data not only in real time, but through our reporting solution here, you can collect and monitor and report on that data historically as well. So again, project friendly, tenant friendly, and real time, as well as historical analysis and reporting of the client, the destination, and the actual data set. So in this case, we've got 20 events, and there's the actual breakdown of the entire report. So if there's some piece of our canned reporting, we try and do as much of this work as possible and build canned reports and easy-to-use solutions. But of course, customization is king. And so you've got the ability here to take any little piece of that report, reorder it, make it mix and match, and work with your data set the way you need it to work. So it'll parse out that search, and at the end of the day, we'll be able to see, again, the source address, the time. Time as a variable is incredibly important. We've got a very short runway to deal with these kinds of security exfiltration events. And of course, the source and the destination. So all of this being provided by Infoblox's distributed grid and can be deployed as small or as wide as you need on your OpenStack private cloud, in your public cloud deployments, and leveraging any number of those hypervisors that are out there. And that again is our dashboard showing exactly those 3 tunneling events that we caught, went ahead and prevented, and secured the network with. Thank you.
Cool.
Cheers.
Thanks, Phil. And again, I think the key thing about that is the danger of data exfiltration over DNS tunneling. If you have a good SIM platform, maybe it'll catch it after the fact, maybe a couple minutes, maybe a couple hours later, has something look weird, but the data might be gone. So by having something like Infoblox on the DNS side of the house, it gives you that control point. Again, we have unique visibility, we see the traffic going through it, we do reputational, we do behavioral analytics, as well as signature-based analytics to find some of these risk points from a security angle. And then just kind of wrapping up for most of us again here at OpenStack Summit, we're doing this transition. Some people want to be fully deployed across OpenStack completely. The majority of us probably have a plethora of, again, on-prem, public cloud, private cloud, trying to bring them together. And Infoblox really can help with that. So again, we talked about some of the integrations we're doing with the public and private clouds with OpenStack. Phil mentioned AWS, Azure, as well as the on-prem based solutions. But making sure everything works. IP addressing, again, we don't think about IP addressing too often. But what happens if you have all these different environments? You have conflicting IP addresses. These are nightmares that we tend to see across an organization that you really want to reduce some of these risks, as well as DNS naming. I want to make sure as I go from one location, from OpenStack to a public cloud or to an enterprise-based or an on-prem solution, that my naming stays similar, stays consistent. Very important. Infoblox can help you with that, again, across that multi-vendor environment. Those are the key things I wanted to cover today. We have a small booth over here on your right-hand side, my left-hand side. We went through a couple demos, recorded kind of a high level walking through it, but we have some engineers here all week. We're glad to get to you, your more specific questions, and answer any questions you might have along the way, whether it's automation, whether it's scalability, availability, or security. Thank you very much for your time, and enjoy the show.